All right. So we'll go ahead and get started now. Again, we really appreciate you being here. The last day of July, last session of our summer workshop series. We really appreciate those of you who are here for the second time. The first time we tried to do this a couple weeks ago didn't work out so well. So obviously this one's already a better day. Yay. Today we're going to be talking about reporting category 2, force, motion, and energy. And full disclosure, physical science was like the only class in college I really struggled with. So physics is totally not my jam. And I had to do a lot of research on this to really, to get up to speed on it and all. So any one of you who are physics is your thing, you absolutely love it, please feel free to jump in anytime and, let me know what's really going on. So, hold your hats for this one, because oh my goodness, there's gonna be some changes. But again, we want to welcome you. We're going to be looking at the new TEKS today. Remember, these are the TEKS that are effective starting in 2024. Some districts are already implementing them starting this year, especially we've heard like 6th grade is implementing them, maybe 3rd grade, just depending on your district's initiatives and decisions. So they are not actually effective by the state of Texas until starting next school year. We're getting a nice head start on them. Understanding where we're going now is really going to help you as you go through the year to be able to maybe adopt what you're doing to the new standards and have like marked in your place where, oh, this is something I can tweak and this is something I need to completely redo. Like just having that in your brain is really going to be extremely helpful, give you a leg up as we start actually implementing next year. So we'll take a break after we actually meet the new TEKS. We'll talk about how to connect the reporting category to the best recurring themes and concepts, as well as some specific ideas about how the instruction should be taught as far as what the TEK is wanting us to teach our kids. We will have a time for breakout rooms where this is your share-a-thon time. A lot of things are moving around again. Although for this particular reporting category, everybody gets new stuff. So it's going to be really helpful to have that that time with people who are in your same grade level or grade range and be able to share your ideas and lessons. I'll take a quick wrap up and then we will be done for the summer, which is great. I'm sure you're super excited about back to school and you will be so prepared by the time we're done today. So reporting category 2, force, motion, and energy. I used to teach 7th grade for most of my career, so we didn't do a whole lot of reporting category 2. And the one of the 2 standards that we had for reporting category 2 is now gone. Like that whole thing on turgor pressure and tropisms and all doesn't even get taught anymore. And they don't teach photosynthesis in 7th grade anymore. So everything I used to teach in 7th grade is gone. You're going to notice a lot of changes here. So in the past couple of weeks, we've picked on a lot of different grade levels. Today is the great equalizer. Every single grade level has massive significant changes to what you're doing. So at least everyone's in the same boat. No longer just picking on 6th, 7th, and 8th grade teachers or 3rd grade teachers. Big changes here. So we're going to start with our anchoring phenomenon. Of course, we are demonstrating like what a 5E lesson looks like with the way that we're sharing the information today, as we have throughout this month's series. So this is our engage piece. The engage should activate prior knowledge, get students asking questions. It's not necessarily designed to be like instructional as far as I'm giving them information. This particular one is because I felt with this standard, it was really important for us as a group to make sure we had a foundation on Newton's laws. So my anchoring phenomenon is a TED Talk, TEDx for education on Newton's laws. Better?
Yes.
Thank you. Let's try that again.
Have you ever noticed that it's harder to start pedaling your bicycle than it is to ride at a constant speed? Or wondered what causes your bicycle to move? Or thought about why it goes forward instead of backwards or sideways? Perhaps not, and you wouldn't be alone. It wasn't until the 17th century that Isaac Newton described the fundamental laws of motion, and we understood the answer to these 3 questions. What Newton recognized was that things tend to keep on doing what they are already doing. So when your bicycle is stopped, it stays stopped. And when it is going, it stays going. Objects in motion tend to stay in motion, and objects at rest tend to stay at rest. That's Newton's first law. Physicists call it the law of inertia, which is a fancy way of saying that moving objects don't spontaneously speed up, slow down, or change direction. It is this inertia that you must overcome to get your bicycle moving. Now you know that you have to overcome inertia to get your bicycle moving, but what is it that allows you to overcome it? Well, the answer is explained by Newton's second law. In mathematical terms, Newton's second law says that force is the product of mass times acceleration. To cause an object to accelerate or speed up, a force must be applied. The more force you apply, the quicker you accelerate. And the more mass your bicycle has, and the more mass you have too, the more force you have to use to accelerate at the same rate. This is why it would be really difficult to pedal a 10,000-pound bicycle. And it is this force, which is applied by your legs pushing down on the pedals, that allows you to overcome Newton's law of inertia. The harder you push down on the pedals, the bigger the force, and the quicker you accelerate. Now on to the final question. When you do get your bike moving, why does it go forward? According to Newton's third law, for every action there is an equal and opposite reaction. To understand this, think about what happens when you drop a bouncy ball. As the bouncy ball hits the floor, it causes a downward force on the floor. This is the action. The floor reacts by pushing on the ball with the same force, but in the opposite direction, upward, causing it to bounce back up to you. Together, the floor and the ball form what's called the action-reaction pair. When it comes to your bicycle, it is a little more complicated. As your bicycle wheels spin clockwise, the parts of each tire touching the ground push backwards against the earth. The actions. The ground pushes forward with the same force against each of your tires. The reactions. Since you have 2 bicycle tires, each one forms an action-reaction pair with the ground. And since the earth is really big compared to your bicycle, it barely moves from the force caused by your bicycle tires pushing backwards. But you are propelled forward.
It's challenging material for educators and students alike, I think. And the way that the new standards are changing is in the direction of much more depth and much more rigorous understanding of Newton's laws and the process leading up to them, or the foundation leading up to them. Yeah, great. If you're not familiar with TEDx, hopefully you are. TEDx is awesome videos, but I love that one because it does make it very understandable. And one of the overarching themes you'll kind of see for the new standards in general is that it is designed to put more of an emphasis on helping students relate it to their everyday life. And a bicycle, even if kids don't have one themselves, is something that is fairly universally understood. So it's a great example of how to use that in an everyday example. Starting with a force being a push or a pull. One thing you'll see with that is that they've brought that down to an even lower grade level. We start off now in kindergarten understanding pushes or pulls. So even though we didn't teach Newton's laws until 8th grade, and up until that point, there was a lot of foundational kind of building going on. It is so much more intentional now. So that is a really good thing with this new set of standards. So with the new set of standards, let's go ahead and move into, so now that we kind of are thinking in the right frame of mind, right? We've set the foundation with our engage piece. We're going to move on to explore. Explore being how you are going to interact hands-on and start building your own knowledge as your students would in the explore piece. right? We always do explore before explain because we want the students to really start building a base of knowledge that you can then use when you start your explain piece. So I am going to put a link in the chat to our sorting activity, and anyone with the link can edit. So this is an activity we created to help you start understanding the alignment of the new standards. So when you click on the link, you're going to see one slide per grade level. And working in columns, we want to line up the current 2017 streamlined TEKS with the new 2024 TEKS. All right, so there may be alignment and there may not. So find your grade level or whatever grade level you would like to work in. There's a lot less standards for this than there have been for the last two reporting categories. Earth and space and organisms and the environment are both like huge reporting categories. So there's a lot less standards, but they are far more rigorous. So you're going to line them up by putting the blue on the left, the green on the right, and if there is a correlation, we want to see that correlation. So for example, we're using the current standard says use our senses to explore the different forms of energy. And the new standard, it talks about light and it talks about light and talks about magnets, but there's really not one that lines up exactly with this. So I'm going to kind of stick this one off to the side. This has observe objects in relation to each other. There's really not one for that either. And how objects move. So it looks to me like most of these standards for kindergarten are brand new. So we want to kind of do that for each of the reporting categories or each of the grade levels. Does that make sense? Anybody have questions on what we're doing here? Again, you might notice that there's not necessarily a lot of, I wouldn't say there's not alignment between the old TEKS and the new TEKS, but it's, even if there is content in the old TEK that you were teaching, it is completely different from what it is in the new ones. So even if the content or the concept hasn't changed, the way we're teaching it definitely has. So again, reporting category 2 is the great equalizer as far as in for a huge change. So there are some really great things about what has changed, and I think a lot of it has to do with the alignment as far as we're building a much better foundation in early elementary so that by the time they get up to 6th grade, which is now where we start really applying Newton's laws, is in 6th grade, they should have a much better foundation. So if you're looking at your grade level and go, oh my goodness, this is crazy levels of rigor for a 1st or 2nd grader, the best part of it is they'll have a better foundation coming to you. So, so again, everybody's in the same boat. We're all looking at these higher levels of rigor. And I think overall that's going to help how we develop the students' understanding over time. So now that you've had a chance to kind of explore the standards yourselves, we do offer that activity to you as a freebie. This is for reporting category 2. We've done this for all the reporting categories. So you just click on, when you get the after the end of the workshop, you will get a copy of the recording as well as a copy of this slide deck. And the slide deck includes links to all of the materials that I'm showing you today. So you get links to everything, but it really is helpful to be able to see how these standards are changing and actually move and physically like adjust them and see where things fall. So feel free to do this with your team or with your your grade level peeps to really understand as you're diving into these new standards. It's a very visual, very kinetic way of learning, just like our kids need, as do our teachers need. So this helps a lot to really see where things are moving. So we're going to go ahead and take a look at each of the grade level standards as they are changing. So this is we're moving on to the explain piece. And there's some background that we're going to set before we really get into the actual standards. So some overall changes that you will see, kind of an overview of the changes. First of all, the alignment is much better as far as how the standards are arranged. Anything with a 0.7 is force and motion, and anything with a 0.8 is energy. So they have completely separated force and motion from energy. So now you're going to teach, the standards have 0.7, maybe A, B, and C, and all of them are actually doing with an object's motion. And then 0.8 is the transformation or the use of energy. There is a focus on depth instead of breadth, right? So by separating the grade levels, by separating the content, we've deleted quite a bit of content. The depth is definitely there. So it allows you to go more deeply into particular concepts than maybe prior you were able to. So that's again going to help with that level of rigor. It gives you you have the time to do depth because you're focusing on one specific idea instead of all types of energy. You're going to focus on sound energy or light energy. So that really helps quite a bit. Again, we're all new. Every grade level is new content or new focus. So the way that we are teaching this content has completely changed. One of the focus is on hands-on. It really, really is very hands-on. The new TEKS make that even more clear. So really, of course, the best way to learn this in the first place was by hands-on investigations, but now a lot of the standards actually say plan and conduct a descriptive investigation or a comparative investigation or a engineering design process. Like the standard requires you to have the students doing their own investigations. Also, lots of creating their own graphs, actually making the graph, and that starts really early, a lot earlier than it used to. So having them actually make their own graph and decide what kind of graph is best or what kind of graphic organizer is best to display this data is going to become really important. And then analyzing data from their own investigations. So all of those, that phrasing, those words have become more clear in the new content. So this is one you are just going to have to do hands-on. The last thing is the way that they are changing even the verbiage. So in early elementary, we are really setting up the foundation for Newton's laws. So we're no longer talking about how objects move like spirals and zigzags and things like that. It is very specific to pushes and pulls, and that starts in kindergarten. In kindergarten, we talk about how pushes and pulls work, and then it just builds on there for all the way up through 5th grade until we move into Newton's laws in secondary. So that's really going to build a better foundation. Again, it's taken out a lot of the other types of movement in order to focus on force and motion of specific law, how they specifically build in Newton's laws. So the laws have been changed in secondary. They are separating them by grade level. So 6th grade now teaches Newton's 3rd law, 7th grade teaches Newton's 1st law, and 8th grade teaches Newton's 2nd law, as well as how to apply all 3 laws simultaneously. So there's a big misconception that students tend to end up with in high school that when there's some kind of force acting on an object, it's one of the 3 laws. No, it's not. It's like all of them act together. This is how objects move. But to eliminate that misconception, they're really focusing on how they act simultaneously. So you'll see there is a better alignment, and hopefully not all grade levels are being overwhelmed with a specific piece of knowledge. And we also have separated out the types of energy. So we're not just separating motion, we're also talking energy, especially in early education. Now, instead of teaching all the different forms of energy, you teach a specific one and you go really in depth with it. So kindergarten is light, 1st grade is heat, 2nd grade is sound, and 3rd grade is mechanical energy. And the other types of energy aren't even mentioned. In secondary, once you get past 3rd, kind of 4th grade, really just hones that a little bit, but it also talks about how forces, how energy is transformed or transferred. The words conservation of energy, that law of conservation of energy has been completely removed, but the concept of transformation of energy is alive and well throughout the standards. So there's a big focus on transformation or transfer, and then how do we apply that use of transformation of energy. So how does chemical energy in a battery become light energy in a flashlight? And obviously it goes through that, transition to electrical energy and then to light energy, and being able to understand how it's changing a lot, but it's never, you're not losing energy, it's just being transformed. So again, big changes. One of the things that's changing a lot is it's specific about the types of investigations that you need to use. We did an entire workshop on the new science and engineering practices and went in depth on what each of the types of investigations are and what it might look like in a different level of classroom. So I've included a link to the slide deck for that workshop because it does have separate slides for each of the different types of investigations and ways that you can implement it. This is the link to the video for that workshop. But just to kind of give you a little bit of background, a lot in early elementary up till 4th grade, we're really talking about descriptive investigations. So there's no measurement involved. They're really just wanting, there's no like calculations or numbers. They really just want them to make that observation, use describing words for how things are changing. Or what's happening in this investigation, just be able to put into words and then into writing, as their writing skills develop, what is happening and what are they seeing. The other one you're going to see a lot for this reporting category is experimental investigations. This is when they're testing that cause and effect relationship. Obviously that goes really well with force and motion and how things are changing. This is where they need to start learning variables and what is an independent variable and a dependent variable. And you'll also see a lot of engineering design challenges actually written into the standards. So this one's going to have them actually creating an object that makes sound, or creating a way of testing how things move with this type of force. So that's really fun. I love the engineering part of that. I think it's a great way to have students learn, is by actually not only learning the science, the why, but then applying it, which is that solving a problem using engineering. So I think it's going to be a lot of fun, but you need to know that there are definitely engineering challenges built in. You'll also see field investigations. This is real world, take them outside of the classroom, conduct an experiment in the field. So this is also built into some of the standards as far as being able to observe the types of energy and energy transformations that they see in their own everyday lives. And that's, again, one of those big focuses, is we've changed to looking at how students see this in their everyday life. With that, and knowing that a lot of the standards say students must plan and conduct an investigation, that can be really intimidating. Like, oh my gosh, do you want me to just hand over like this whole investigation to the students? They're going to be completely lost. And absolutely, they would be completely lost. So we really want to make sure we're scaffolding how to do that. In the standard, it says plan and conduct. It doesn't say they have to do every single part of every single experiment. So make sure that you are providing the appropriate scaffolding. And one time that may look like, I'm going to give you these tools, and you can then use what I have given you, and only what I've given you, to plan an investigation. So you're reducing the scope of what they have to do by giving them the materials to look at. Maybe in one time you're going to give them the experimental plan. You're going to tell them you're going to do this step, and this step. And they have to do everything else around that. They're going to come up with the question, and they're going to come up with the ways to analyze the data. They don't have to do all parts of every investigation. So it would be too much to hand to the kids and just say, plan and conduct an investigation on how light works. That's not going to happen. They're going to be overwhelmed. But if you give them a mirror and a flashlight and said, plan an investigation on how light works, then they're going to be able to understand that they can, start maybe moving the mirror in different directions and creating their own light maze or something along those lines. So it really does help to have them scaffold that. And in each investigation you do, you might change up what you're providing to give those students those skills. And then maybe by the time we're in high school, the kids can actually plan and conduct an investigation entirely on their own with no input from the teacher, but that's a lot to build into. So start small. Start with what your students can manage, especially as we start the new standards. This is all going to be new to them too. We're asking them to do a lot of new skills, and we're going to need to support them as they implement it. So that's just kind of for your peace of mind, some ideas for you to be able to scaffold and feel more comfortable with some of these new standards. With each of the standards, I have included a link to EduSmart side-by-side. So we have created this side-by-side document. It's an awesome document as far as being able to see, and I'm just going to scroll down. This is first grade. Be able to see exactly what is changing and what's new. It highlights, if there's no standard that lines up to this, that means there's no correlation between the old standard and the new one. So blue is the 2017 streamlined, green is the new standards, and you can just kind of see where everything went, what is actually new, and then it highlights some of the what exactly is changing, so it gives you that information. So for each grade level, you have a link to that side by side. But we're also going to talk about the main changes for each one. So this is where you're going to get your vertical alignment. This is the explain piece of our instruction so that you can really understand what is changing and how. Starting in kindergarten, again, we are now taking out everything except for pushes and pulls. So we're no longer talking about things like spirals and zigzags and how objects, we're just talking about pushes and pulls. But we start that in kindergarten. So describe and predict, notice the word predict, obviously a higher level of rigor already starting out, how a magnet interacts with various materials and how magnets can be used to push or pull. So we're not talking about magnetic forces yet, but we are getting them the idea that magnets cause a force, even if you don't use the word force. So magnets are used to push or pull things. And then for the energy portion, it is focused only on light energy. So we have to communicate the idea. And obviously there's a lot of ways that students can do that. So it does not have to be written, it can be a picture, it can be verbal, however they can get the idea across that objects can only be seen when a light source is present, and compare the effects of different amount of lights on the appearance of objects. Now, after break, and after we talked about recurring themes, I'm going to show you some great ways of introducing these concepts to students. And we'll look specifically at this one because it is very new. It doesn't say it's new because light was mentioned in the prior standard, but it's obviously, it might as well be new. And then we also are going to demonstrate and explain that light travels through some objects and is blocked by other objects, creating shadows. So that's another higher level of rigor. Talking about shadows in kindergarten. In the other standards, like reporting category 1 and 3, they don't mention shadows again until grade 4. So this is kind of a big one for kindergartners. But again, we're no longer talking about like relative position of objects and the way that objects can move. We're only talking about pushes and pulls. In first grade, for force and motion, it's again talking how pushes and pulls can start, stop, or change the speed or direction of an object's motion. And here you go. Starting in first grade, they get to plan and conduct a descriptive investigation. So it starts way earlier that they need to figure out how to make that plan. And again, you could give them tools and have them come up with a way to use those tools to predict how an object pushes and pulls. EduSmart has a great activity where you put a box, like a cardboard box, in the center of a big square, like you tape out a square on the carpet. And now the students have to come up with a way to move the box out of the square without touching the box. And they can plan and then conduct this investigation that because they have to predict it, because they have to come up with the plan in advance. So they're predicting how pushes and pulls could work. It's fairly simple, move the box. You have to move the box out of the square without touching it. And you could give them a variety of tools to use, like a feather or a ruler. Those kind of things would would easily be able to get them planning ahead, but you're curating the materials, and so you're curating the process for them. In first grade for energy, we talk about heat. So the emphasis is on how heat causes changes, and they don't use the word thermal yet. Thermal comes later on, but we're talking about thermal energy and how it causes changes. New to this grade level is to describe how some changes caused by heat can be reversed and some cannot be reversed. So melting butter can be reversed. Butter is still butter when it's liquid and then back to a solid. But when you cook an egg, it cannot. So it's kind of setting up for the whole idea of chemical and physical changes, but not using it in those terms. Like, heat causes change. That's really the foundation of what they want the students to understand there. All right. In second grade, I'm just making sure I'm looking over my notes here. For force and motion, well, let's look at this. Second grade, everything is new. Like, everything is new. Like, every standard you are teaching is new. So fun. Force and motion, you need to explain how objects push on each other and may change shape when they touch or collide. So that is looking kind of at cause and effect, right? Again, we're really wanting to understand pushes and pulls very, very specifically and in depth. And then again, in second grade, you are planning and conducting a descriptive investigation to demonstrate how the strength of a push or pull changes an object's motion. So this could be really fun. Like, this is a place you could set up some kind of obstacle course, a marble maze. Cars have, you might need little Hot Wheels cars and things like that are going to show when you push it hard, it goes further. When you push it slightly, it goes less. You could even do tug of wars here, that kind of thing, just to understand the strength of a push or pull. So that's that next piece that we're adding. So hopefully already you can tell, even though we are going into more rigor, it is better aligned, and we are building a solid foundation for Newton's laws. So it is much more condensed. We're not quite all over the place like it used to be, but it's very rigorous and kind of hard understanding. And they're being asked to do a lot when they plan and conduct descriptive investigations. In second grade, we focus on sound energy. And so we're looking at sound. All of them are new, or might as well be new. And we're looking at how sound is caused by vibrating matter, but also that vibrations can be caused by lots of things, including sound. So we want them to understand that vibrations don't necessarily always cause the sound. They can be other things. They'll start exploring waves in fourth grade, but sound is made by vibrating matter. We're talking about how different levels of sound are used in everyday life, such as a whisper in a classroom or a fire alarm. And Here's your first engineering challenge. They must design and build a device using tools and materials that uses sound to solve the problem of communicating over a distance. So first of all, I love that they say you have to use tools and materials. What else are you going to use? Air? But anyways, using tools and materials, use sound to solve the problem of communicating over a distance. When I first heard this one, I was like, are you kidding me? How are they going to do that? But we start thinking about it. The old, cup on a string is obviously one way that they could do it. They could create drums that they can make their own like Morse code out of. Did you know you can make a whistle out of a straw? Simple way to do it. And then again, they can communicate. Just says over a distance. It doesn't say how far. So we want to make sure we're building a device, some kind of cool engineering project where they use sound. So there's actually lots of ways you can do this, but it is an engineering design challenge that is built into the standards. So it's one of those things you can't really get out of on this one. When we move into third grade, it's again still focusing on pushes and pulls. In fact, they brought this pushes and pulls down from fifth grade. It's still not using the word force, but we're just building that foundation for force. So it has expanded as far as for this standard, we want to demonstrate and describe. So the verbs are more measurable. Specifically, they wanted them to be able to measure, you as a teacher to be able to measure success or understanding. Forces acting on an object from a distance or in contact, including magnetism, gravity, and pushes and pulls. So the big change here is objects from a distance or in contact. So you need to understand that even though, the moon is far away, gravity is still acting on it. Even though magnets aren't touching necessarily, there's still magnetism in between them. And the same thing for pushes and pulls. Here again, they plan and conduct a descriptive investigation to demonstrate and explain how positions and motions can be changed by pushing and pulling objects such as swings, balls, and wagons. Not a huge difference here, except that they are expected to plan and conduct the descriptive investigation. So before it was kind of, I think it was like explain or just demonstrate. Now they have to actually carry out their own investigation. In third grade, again, I will say has gotten lucky. Like the least amount of changes are happening here. It's more in depth for sure, and you're adding a little bit of specificity, but overall this grade level is getting off slightly easier than some of the other grade levels. So y'all have a lot to do in other places, I understand. For energy, we're focusing on mechanical energy, but this is the first time that they put all the energy together. So identify everyday examples of energy, including light, sound, thermal, and mechanical. Notice we've changed the term here. It's no longer heat, it's now thermal. So when they teach it in first grade, it's just heat energy, and now we're giving it its proper name as thermal energy. And then the new one is the mechanical energy. Plan and conduct investigations that demonstrate how the speed of an object is related to its mechanical energy. And the big part is that we're relating force to mechanical energy. Force is a push or a pull, and how does that relate to the movement energy of objects? So a marble roller coaster here would be a really great way of doing that. Ramps, so different levels of ramps. When I have a ramp that is really high, it's going to make my car go much faster than have more speed than if my ramp is low. It's not going to have nearly as much speed. Now, they don't have to put numbers to it at this point. They just have to describe. So it helps, more speed, less speed, that relative terms as opposed to actual measurements. So that's third grade. Also, I do want to point out, starting in third grade, the actual knowledge and skill statement and we'll look at it here, has changed to include patterns. So let me find, here's force and motion. So this is the actual knowledge and skill statement, and it says, within the physical environment, students recognize that patterns, relationships, and cycles exist in matter. And then you go on to learn to investigate. So this recurring theme of patterns is built into the knowledge and skill statement. So we want to make sure that we're pointing that out to students, that this is a pattern. Every single time that there's more speed, it causes a bigger push. Like that's the kind of patterns that we're really looking for. So keep that like kind of in the back of your head, that patterns it needs to be put in relation to patterns. Force and motion, same thing, or I'm sorry, fourth grade, same thing. It's built into the knowledge statement from here on out that patterns are important. Fourth grade only has one for force and motion, and it is plan and conduct descriptive investigations to explore the patterns of forces such as gravity, friction, or magnetism. Not a huge change here other than they're doing the planning and conducting of descriptive investigations and adding the RTC of patterns. Here, the energy focus is on electrical energy. And while this is not a new standard, it might as well be new because this is the first time that we've used waves down in this low of a grade level. So it says investigate and identify the transfer of energy by objects in motion, waves in water, and sound. So we're looking at how energy moves from one object to another. And we have a great instruction module on this with EduSmart. We'll show you kind of how it gets scaffolded. But this is a big change. So we're really looking at, they need to understand energy in a much more in-depth way. It used to just be more like describe the different types of energy. There's not much of that now. It's not describe the type, it's how does energy work? So lots more rigor. Identify conductors and insulators, really not much change to that other than the verb, which is identify as opposed to differentiate. Yeah, huge changes here. And then C is to demonstrate and describe how electrical energy travels in a closed path that can produce light and thermal energy. So we no longer say a closed circuit, it's just a closed path. In fact, that word circuit no longer, well, I think it actually is in like 5th or 6th grade, but now we're looking at why it travels in a closed path, because it can then produce light and thermal energy. So it's really adding that why piece, and this is an understanding that it's a system. I think that's why they added in or changed the terminology to closed path, is that it makes it more of a connection to this is a system where electrical energy is transforming into something else. So we really want to push that systems recurring theme. So yeah, really starting in 4th grade, you see huge changes. Through 3rd grade, it's deeply foundational. Understanding pushes and pulls, understanding how pushes and pulls work, understanding that pushes and pulls happen from a distance. Like you're really building that understanding of what it all is, and in depth into each of the energy types. But man, starting in 4th grade, it's application and it's rigorous. 5th grade, also massive changes. Focus here is on, well, for energy especially, is on transformation. 7A is new. This is actually coming down from 6th and 8th grade. We're investigating and explain how equal and unequal forces acting on an object can cause patterns of motion and transfer of energy. So again, the idea here is forces acting on an object, and we're looking for the patterns of that, so that every single time the push is bigger going this way than it is this way. The object is going to move that way. It's setting them up for Newton's laws. And then we get to design a simple experimental investigation. Notice now it's an experimental investigation. That means you have variables and they actually need to understand what like an independent and dependent variable and all of that. So we're designing a simple experimental investigation that tests the effects of force on an object, such as a car on a ramp or a balloon on a rocket string. So if y'all don't know what that is, you attach a balloon to a straw and you close one end, you kind of attach it to a string, and then when you open the balloon, the blown up balloon, the air pushes out and the balloon is propelled the opposite direction. It's a really fun experiment for the students to do, but they are the ones that need to design the experiment. So again, we want to test the effective force on an object, but the kids are the ones who have to design that experiment. You can scaffold that so many ways, either by giving them the objects or showing, okay, this is what we're going to do. How are you going to collect your data? What data do we need? What question are we testing? Drawing conclusions. Like, they do not have to do all of it themselves. For energy in 5th grade, we are again changing to transformation. So there's no, we're no longer talking about the law of conservation of energy, but we are showing how that happens. So investigate and describe the transformation of energy in systems. So they've added that recurring theme of systems, such as a flashlight battery that changes chemical energy to electrical energy to light energy. That's a lot more rigor than it used to be. Like, it used to just be kind of, know the forms of energy. Not so much anymore. B says demonstrate that electrical energy in complete circuits can be transformed into motion, light, sound, and thermal energy, and identify the requirements for a functioning electrical circuit. Now, this is not completely new. You had to know what a closed circuit was before and a complete circuit, so that part's not a huge difference, but it's just much more specific about what they're asking for. And they've added motion to light, sound, and thermal energy. So there's just a lot to unpack with this specific standard, because they have to know everything and how an electric circuit works, what an open circuit is compared to a closed circuit, why a circuit wouldn't work because it's open, not closed, or whatever that might look like, and then how you can transform it into all of those different forms of energy. And then we're also going to add in reflection, refraction, and absorbed energy. So this is really just kind of clarified. It cleaned up the standard a lot. But it now says demonstrate and explain how light travels in a straight line and can be reflected, refracted, or absorbed. So that one's not a huge difference, but it will be, I think the absorbed is the biggest one. It was already talking about reflected and refracted, but absorbed is a little bit different. Oh, okay. And all of that wasn't bad enough. So now we're going to go ahead and get into middle school, which I left this in from last week because here we go again. Breathe in, deep breath. It's going to be okay. We got you covered. We got your resources. 6th grade, all new energy, all new forces and motion. So good news, we'll start with we deleted that relative position and the direction and speed of objects by unbalanced forces. So they've started to learn about balanced and unbalanced forces in 5th grade, and the rest of that's been moved to 7th and 8th. Calculating speed is now in 7th grade. Measuring and graphing changes in motion is now in 7th grade, and it's completely deleted that inclined plane and all simple machines. So we no longer talk about simple machines in elementary or middle school. They deemed it was not developmentally appropriate. So instead, We get to identify and explain how forces act on an object, including gravity, friction, magnetism, applied force, and normal force using real-world applications. Now, I'm just going to tell on myself a little bit. I have a master's degree in science education, and I had to look this stuff up. So please don't feel bad if you're like, what? Unless you're a physics like major, then this stuff may be challenging for you, and that is okay. And we're going to support you with that. Also, in 6th grade, we now need to calculate, that should say net, the net force on an object in a horizontal or vertical direction using diagrams and determine if the forces are balanced or unbalanced. So we're not noting the change in position and the speed anymore. We're just, are they balanced and unbalanced? And what is the net force acting on an object? We will show you how to do that in a moment. It's going to be okay. And then this is a fun one too, Newton's third law. So we saw that in the beginning. That was my anchoring phenomenon so that we could all kind of have a refresher course on Newton's laws. This is changed quite a bit. It says identify simultaneous force pairs that are equal in magnitude and opposite in direction that result from the interactions between objects using Newton's third law of motion. So one thing that you'll notice with Newton's laws is that it's focusing on how and why would I use this. And it's the force pairs is also called action and reaction pairs. I had to look things up, so I'm going to share with you what I looked up. This photo credit goes to gosciencegirls.com, really great site for understanding forces. So a normal force is the force that it's the pushing force that the surface exerts on an object to prevent it from falling through the surface. So the normal force is just the force of the table pushing up on the box or the floor pushing up on your body to hold you up so you don't sink into the ground. Just never heard it referred to in those terms before. The applied force is the push or pull. So it's how the object moves. You're applying force to move the object. That is the applied force. The other forces acting on it are, of course, the weight of gravity pulling down, acting against the normal force, and then the force of friction. So normal force and gravity are, generally speaking, a simultaneous, so it calls it a simultaneous force pair because they are equal in magnitude. Right? So the normal force is pushing up, the surface pushing up, gravity is pulling down. Those two are obviously in equal magnitude or else it would be moving up or down, and it's not. So that is a simultaneous force pair. In Newton's third law, this is where every action, there's an equal and opposite reaction. This explains that when one object exerts a force on another object, the second object exerts an equal force in the opposite direction back on the first object. And here's 3 examples for you. The key to each example is that in these interactions, the forces are equal in magnitude and opposite in direction. So one is going one way, one is going the other, but they are the same magnitude. That is a simultaneous force pair. So that's that was that key terminology that has changed. Understanding a simultaneous force pair. So when you jump off the diving board, you jump, your feet push down, and the board exerts an equal pressure up, and so it lifts your feet up into the air. Walking on the ground, you push your foot down on the ground and you push backwards, and the ground is pushing forwards, so that moves you forward. Sitting on a chair. I like this example because there's no real motion involved, but the forces are still acting on you. So when you're just sitting, your body is pushing down on the chair. The force of gravity is pulling down on the chair, and the opposite force is pushing, that normal force is pushing up, supporting your body and supporting the chair. So those are 3 great examples to help you in your own understanding. We use other examples in EduSmart, and we'll be showing you an instruction module to help understand this as well. So that was a really big change for sixth grade, is understanding these different types of forces and then being able to apply them as simultaneous force pairs to Newton's third law. In energy, everything is either new or might as well be new. So this is a big, huge change as well. We are comparing and contrasting gravitational, elastic, and chemical potential energies with kinetic energy. The former standard was just potential and kinetic energy. So now we've made it much more specific. We're looking at these specific types of potential energy and comparing that with the energy of motion. So we'll have to learn a lot about those three specific ones. B is describe how energy is concerned through transfers and transformations in systems. Again, this used to be like the law of conservation of energy. And it's still the same concept. It's just a little more complex as far as transfer or transformation. And then the specific examples were electrical circuits, food webs, amusement park rides, and now you have added photosynthesis. And this is the only time photosynthesis gets taught. So it's moved down from seventh grade. We used to, in seventh grade, spend an entire week or so on it. This was its own standard, and now it's just part of this already highly in-depth standard. So it's just one word that adds a whole lot of complexity. But it's really fun to teach. I actually really enjoyed photosynthesis. It's fun, and it does make sense to put it in this context, but it is going to add a little bit to it. And then, because that wasn't enough, explain how energy is transferred through transverse and longitudinal waves. So waves is new. This is setting up the foundation for the electromagnetic spectrum and how energy transfers through waves in the electromagnetic spectrum. So we just need to know transverse and longitudinal waves. We'll show you an example of that here in a minute. To help with that, you have deleted the law of conservation of energy. Now you just teach it as the transfer and transformation. We moved conduction, convection, and radiation to seventh grade, and then the movement of thermal energy to seventh grade. So there is a few things that were taken out to help with that scope and sequence for sixth grade. But I'd say this is definitely fourth grade and sixth grade are definitely some of the most highly impacted as far as the amount of standards, the amount of instructional time that you're going to need on this particular reporting category. Moving to seventh grade. Everything in seventh grade is new. So we used to teach two standards in this reporting category, and it was on the transfer of energy in an organism, like digestion, chemical energy, and that's gone. And then tropism and turgor pressure and circulation of blood, that's gone. So what you do have is all new, but they have taken out those two, so that does help a little bit. A for force and motion, now you calculate average speed and distance. Calculate average speed using distance and time measurements from investigations. So that's moved from sixth grade. It's more specific that they have to do their own investigations to get the measurements. This was changed because this standard wasn't, or the calculations needed weren't really taught until seventh grade. And so it didn't make sense to teach this in sixth grade when they didn't have the math for it. So now we have the math for it in seventh grade, and they are kind of better aligned with the math standards. B is distinguish between speed and velocity and linear motion in terms of distance, displacement, and direction. So one misconception that students would often have is the understanding of acceleration versus velocity. And so they've completely separated those terms to help avoid that misconception. So acceleration is taught in eighth grade, velocity is taught in seventh grade. And then the last one, or C, is measure, record, and interpret an object's motion using distance time graphs. That's the only thing that's really changed there. They moved it from 6th grade, but it's specific to distance time graphs. And then D is analyze the effects of balance and unbalanced forces on the state of motion of an object using Newton's second law of motion. For energy, again, it's all new. And the key here is that it's again, using systems and patterns as the recurring theme. So investigate methods of thermal energy transfer into and out of systems, including conduction, convection, and radiation. So your 6th grade teachers are already teaching those terms. They're going to have great lessons for them. All you really need to do is focus on how that is a system. And then this B kind of goes with that. Investigate how thermal energy moves in a predictable pattern from warmer to cooler until all substances within the system reach thermal equilibrium. They've thrown in that term thermal equilibrium. That's new, but it kind of builds for high school so that they have that idea. But really it's just, heat moves from warmer to cooler until everything is the same temperature. So the concept's not hard. The vocabulary may be a little harder. C is explain the relationship between temperature and kinetic energy of particles within a substance. This is all brand new. And it's setting a foundation for high school. So we're talking about temperature and kinetic energy, how a higher temperature increases the amount of kinetic energy in a particle. So the challenging thing about this one is that at this point, they don't necessarily have a really strong foundation in particles because of matter and energy, the way that is aligned. So we're kind of, it will be a little bit more challenging with that. They will know like particles within solid, liquids, and gases. And so I think you can use that to kind of explain more of that connection between temperature. But that one's all brand new, so it'll be interesting to see how that one falls on the kids. I don't think it'll be a huge challenge. 8th grade hasn't necessarily all changed. In fact, they've taken out some stuff from 8th grade that will help you a lot, but the focus of it has changed a little bit. So we want to avoid that misconception that you can apply Newton's laws individually. Like, oh, this is a roller coaster. It's following Newton's first law. No, of course, all Newton's laws are acting on it simultaneously. So they really kind of change the wording to focus on that. So the first one is calculate and analyze how the acceleration of an object is dependent upon the net force acting on the object and the mass of the object using Newton's third law of motion. So again, it's much more specific, and it's calculate and analyze. So that analyze is a whole new level of rigor. However, acceleration is only taught in 8th grade. So they really are separating acceleration and velocity, and that helps to avoid that misconception. And then the second one is to investigate and describe how Newton's 3 laws act simultaneously within systems, and then it tells you the specific systems to look at, and those systems haven't changed. So vehicle restraints, sports activities, all that's the same as what you were doing before. The only thing is that we're showing how they act simultaneously. So it's changed a little bit. This is a really good change. They have deleted the differentiation between speed, velocity, and acceleration because they are separating those 3 concepts within grade levels. And then for energy, it's all new. And this is where the big change is for 8th grade. Compare the characteristics of amplitude, frequency, and wavelength in transverse waves, including the electromagnetic spectrum. So we were already teaching some about the EM spectrum, but this is now, you don't have to calculate the amplitude, frequency, and wavelength, but you have to be able to know the difference, know what they are, and know how they work within the whole spectrum. And then taking those waves, those electromagnetic waves, in applications. So what are the everyday uses of these? That used to be real specific to how do scientists explore the universe using the electromagnetic spectrum. Now we're focusing on practical applications. How is it used here on Earth in everyday ways, such as microwaves and x-rays and things like that. So that's actually, I think, a really good change as well, but it will change how you teach the electromagnetic spectrum. So there you go. Deep breath again. It's a lot. It's a lot of changes. Every grade level is affected, but it is, I think, more focused to get up to this level. Sixth grade has massive changes, but they will have a better foundation of the, everything that they're learning. They'll have a better foundation, so it should be easier as you move into that. One big thing is a lot of schools, and this is not a criticism of any teacher or any district or anything. We know how challenging it is to fit science in at the lower grade levels. Like early elementary, you're just trying to get them to read. But you can see, especially here in this reporting category, how important the that vertical alignment piece is. Like they have to have these foundational pieces. And so it's going to become so much more important that they get the understanding from the prior grade level, or they'll be lost by the time they get to fourth grade. Again, by the time they get to sixth grade, and then being able to apply those. And a lot of times it's not until fifth grade that students start getting actual, devoted science class periods. So I'm sorry, early elementary teachers, this just adds more to your plate, but it is what it is, and it's going to be really, really important. So what comments, observations, questions, anything you're noticing about the new standards as far as the width and breadth and depth?
Not only the rigor, they're being exposed to the different vocabulary. I noticed that it's changed. Like as you've gone through, it's like, okay, so now you have to start preparing, getting your minds ready for when you introduce this lesson, these words. Because even though we might know them, they're definitely not going to know them. I'm like, huh? So that's definitely something that I've noticed. The vocabulary has definitely changed.
Absolutely. And because vocabulary wasn't challenging enough, let's go ahead and throw in some, big fancy words. They're using the correct terminology, which is great, but it is a lot.
Yes, I say they're moving the vocabulary down. Like maybe in sixth grade, they had this particular vocabulary word. Now they're moving it down to a lower level to where, it's getting more exposed at the lower level versus sixth grade.
Agreed. Absolutely. Yeah, so they're building that foundation for it, but it's a lot for those younger grades to be able to understand. Yeah, in the chat, the scope and sequence, we do have a scope and sequence that we've put together for the new grade levels. We will include that for you in the links for the lessons or when we send out the links for today. Let me make a note to make sure that scope and sequence. Now, caution, the scope and sequence is specifically for the 2024 TEKS. You cannot apply it this year unless you are teaching the new TEKS. So we do not have a scope and sequence for the 2017 TEKS, only next year. Yeah, so big changes to vocabulary, not as bad in 7th and 8th grade. I kind of agree with that. The alignment is way better in middle school. And so I like the way it builds. It really builds well, and it hasn't always done that. So I think that's a good change. Absolutely. Thank you. Yeah, thank you so much for your patience on all of that. And we'll make sure and get them out to you today. So connecting the recurring themes and concepts, you could really, this one's kind of basic. We'll go over it real quick because you can see exactly from the standards themselves where they want you to connect the recurring themes. They want to see the patterns in motion and force. Every time that something happens, this is how an object moves. It is a law in science. They really want to enforce that pattern. And then really looking at systems and systems models and the parts of a system and how they work together, as in a circuit, as in a just like with our reporting category 4 and organisms in the environment, all of these things are part of a system, and they depend on each other to function. And a big part of that is kind of that law of conservation of energy and law of conservation of mass, where things are transformed, but they are never they don't just poof, they don't go out of existence. Cause and effect is another easy way to really investigate, especially the laws of motion. Because you can clearly see when I do this, something happens, when I pull, when I push, something happens. So using that cause and effect to frame the discussion is very helpful. And then stability and change. This is again, that change component, that transforming, transferring is really important as far as both energy and the transfer of energy in motion. So there's some suggestions for you in there. Again, for patterns, they have actually changed the knowledge and skill statement to specifically reinforce patterns. So this needs to be your foundation for instruction, is seeing the nature of forces and their patterns of interactions, and how energy is everywhere and can be observed in cycles, patterns, and systems. All of those patterns of forces, gravity, friction, waves is going to be a big one, pushes and pulls, and the effects of pushes and pulls, as well as this concept of thermal equilibrium, which I just think is fun to say. But that's the movement of heat and the way, conduction, convection, and radiation. So all that pattern work, cause and effect, you can see is built into anything. When something moves, there's a cause, and the movement is the effect. And one key here is that starting very early, I think it's in second grade even, they want the students to be able to understand that they don't have to touch in order to influence each other. So magnetism, gravity, all of those things, you don't have to actually be touching for the effect to be felt. It can be an invisible force. So we really want to start that foundation of not having to be in contact, starting very young. And then systems and systems models, electrical energy in a closed path or circuit, that transformation of energy within a system. Photosynthesis is a system. From energy flowing through the system, Newton's laws, and again thermal equilibrium. All of those are systems that you can scaffold on. And then stability and change, that again transformation. Anytime you're getting transfers or transformation, it is the recurring theme of stability and change. So we link all of the side-by-side documents on each page, but here's also a link specifically for you for, make sure I'm still sharing my sound, for all of them together, as well as this nice little one pager for recurring themes and concepts. This is a freebie for you. It shows all of them. And like I said last week, if you weren't here last week, one way that I've heard teachers using these is to actually put like a sticky note and show the recurring theme that we want to be connecting to. So if we're talking about patterns in motion, I will actually point to, this is what we're using as patterns. So it's a great way to really hone your students' attention and give them a tool to use. That's kind of what that recurring theme and concept is a lens in which to put this new learning so that they already have a background in how to use it. And patterns is a really good one for that. But that's a freebie. So the link is on the slide deck. And then let's go ahead and, so this is like our instructional time. We're going to elaborate a little on some of the concepts that we've been talking about. Ways that you can begin this level of instruction. So light was the focus for kindergarten. And this is such a simple way of introducing this concept. It was talking about how different levels of light, how different objects appear in different levels of light. So I have a cabinet here, and I'm going to shine a flashlight on different parts of the cabinet. The effects of different amounts of light on the appearance of objects. I mean, so simple, and yet it shows exactly what we want them to see. This is really just giving them, they probably understand this concept. We're giving them the vocabulary for it. So this is an anchoring phenomenon. I would show this video to my students and say, okay, what do you see? What do you notice? What do you wonder? They're going to be like, what is that thing? What is the black thing? What is the red thing? But it's going to get them talking, and we're all going to have this shared experience, and that way we can really build, have that time in class together. And so that's one example of ways that we can do that, turning on the light. In second grade, we talk about sound being made by vibrations. And I'm going to show you an activity. It's actually for a different grade level, but oh my gosh, is this like the best way to show how sound works? Like, show how sound works. So simple. You can do this as a demo. So again, the key to this standard is demonstrate and explain that sound is made by vibrations or vibrating matter, and that vibrations can be caused by a variety of means, including sound. And this is a great visual. So we want to make science really concrete for our students at this level, and that's a great way of doing that. These little lab videos are coming out with our the new product for the new TEKS. So you'll be seeing these for every one of our activities starting next year. So that's kind of a little preview for you too. So we talked a lot about the effects of force. This is a tricky one. So it starts really in third grade, where it says demonstrate and describe forces acting on an object. It continues through fourth, fifth, and sixth to build up to understanding Newton's laws. So I'm going to show you the instruction module here, because this is a sixth grade instruction module on the effects of force. It builds in all of the concepts starting in third grade. So we're talking magnetism and gravity and how those things, friction, and how those things affect a force. And then it builds into the transfer of energy, including waves. And that's a brand new concept in fourth grade, is that transfer of energy through waves. So there's this one instruction module is huge, truly. It encompasses so many different concepts that they'll be learning. This is one, and again, this is simplified in fourth grade from what I'm going to show you. So we have one for every grade level, but this incorporates all of that instruction. So it's a little bit longer than some of them, but there's just so much to unpack here. Oh, come on. Okay.
That sure does look heavy. Joshua and Danielle are using all their energy to push and pull their luggage to the car. In physics, pushes and pulls are known as forces. The effect of a force depends on the direction in which it is applied. For example, if Danielle keeps pushing her luggage downward, it will not move anywhere. If she wants it to move toward the car, she will have to push it sideways in the direction of the car.
So of course, with our instruction modules, it has the built-in pauses so that you can lead, some kind of interactive discussion with your students, have them talk about it, have them bring their own information to it. So we'll kind of skip through these pauses, but just know when you're actually teaching this is a great place for you to have those collaborative discussions, get the students using vocabulary and having them talk with each other. That student speak is so important.
Along with the direction, how big or small the force is also important. Danielle has applied quite a bit of force to push her luggage into the car. But if she applies the same amount of force to push the car doesn't move at all. The car doesn't move because its mass is greater than the mass of Danielle's luggage. As a result, the car has a greater tendency to resist any change to its state of rest. If Danielle wants to move the car, she needs to apply a lot of force. There are forces acting on the car even when Danielle is not pushing it. The first force acting on the car is its weight, which pulls it downward. At the same time, the ground applies an upward force on the car. This force is perpendicular to surface the car is on, and is called the normal force. Since these two forces are equal in magnitude and opposite in direction, they cancel each other out, so the car does not change its position. Forces that cancel out each other are called balanced forces. There are normal forces acting on Joshua and Daniel too. What do you think would happen to them if there was no normal force? If there was no normal force, they would slowly sink into the ground because of their weight. What will happen if Joshua and Danielle push the car from opposite directions using the same amount of force? If both of them apply equal forces in opposite directions, their forces will be balanced and cancel each other out. As a result, the car will not move at all. If Joshua uses more force than Danielle, their forces will be unbalanced and will not cancel each other out. If two unequal or unbalanced forces act on an object from opposite directions, the net force acting on the object is the difference between the two forces. The object ends up moving in the direction of the greater force. In this case, since Joshua's force is slightly greater, the car moves a little toward Danielle. What will happen if Joshua pushes the car from the same side as Danielle? Since the forces exerted by each of them are in the same direction, they add up and the resultant, or net force, ends up moving the car a greater distance. Forces are measured in units called newtons. What is the net force on the car and in which direction will it move?
So here they're actually calculating and predicting the net force on an object. So they would just add these two numbers together, and you might have to walk them through that and work out how they're going to move together. And here I'd also point out that these two numbers are equal and therefore balanced. So there's a lot to show with just this one graphic.
The weight of the car and the normal are equal and opposite. They are balanced forces. Since Joshua and Danielle are applying force in the same direction, the forces are unbalanced. The net force of the car is the sum of the two forces and equal to 490 N. The car will move in the direction of the net force. Joshua and Danielle have finally managed to push the car so it is moving. Why is the car slowing down? The car slows down and eventually stops because an invisible force called friction is acting between the tires of the car and the surface of the road. Friction acts in the opposite direction of the motion of the car's tires. In this case, the force of friction represents an unbalanced force. An object moving in a straight line will continue to move with a constant speed unless it is acted on by an unbalanced force. Let's observe another well-known invisible force at work. If Joshua throws one of his shoes up in the air, why does it fall back down to the ground? The force of gravity brings Joshua's shoe back to the ground. Gravity is the pull that all objects exert on each other. In this case, both Earth and the shoe exert a force of gravity on each other. The amount of gravitational force an object has depends on its mass. Because Earth is much more massive than the shoe, the force of gravity exerted by Earth is considerably larger than the force of gravity exerted by the shoe. In fact, the force of gravity exerted by the shoe is so tiny that it is of no consequence at all. The net unbalanced force at work is that of Earth's gravity. Earth's gravity pulls on the shoe after it is thrown upward, makes it slow down, stops it from going higher, and brings it back to the ground. As you can see, unbalanced forces can even change the direction of a moving object. Danielle made a model of a rocket in space that appears to be defying gravity. Why is the model of the rocket not pulled down by gravity? The rocket is held up by another invisible force called magnetic force. Magnets attract objects made of iron or steel like this paper clip. When the magnetic force of attraction is more than the force of gravity, the net force will be in the direction of the magnet and causes the object to move toward the magnet. Magnets also push or pull each other. The like poles of two magnets attract each other while their unlike poles repel each other.
All right, so yeah, as you can see, that is a lot. That is 6th grade, 6.7 A, B, and C. It's talking all the way through gravity, friction, magnetism, applied forces, and normal forces, being able to calculate the net force on an object, and identifying simultaneous force pairs. So there's a lot to unpack in that one particular instruction module. I might take chunks of this because it is so much. And I do also want to point out, I know it's a little bit of a rough video right now. It is a work in progress. Like our platform is like 99% done for the new standards, but we are going to smooth out some of the AI as far as the talking that was going on. So please don't judge too harshly on that, because it is still being finalized a little bit, perfected, we'll say, to be our normal quality of video. But I wanted to show it to you, even though it is a work in progress, because it really hits home on like everything. That is just 6th grade. That is the level of information, the level of expectation that 6th graders need to understand. So again, you can see why it is so incredibly important for all of our grades K through 5 to really be building in those foundational pieces, more so than ever, because by the time you get to 6th grade, they have to understand all those words, all those concepts. Like, whew, that's a lot. It's a lot to ask of our 6th graders. Right. Yeah. So, and it helps you understand that vertical alignment of why we've brought so many of these really high level terms and high level concepts down to lower grade levels. Because by the time they get there, they need to understand all of that information about the way that force affects an object. And that's what that overall, like, that's the key to that standard, is how forces act on an object. But we're talking a lot of different forces, and then being able to calculate those forces, and then being able to apply how we calculate those forces, which is through Newton's third law. Phew. But it's going to be okay, because again, even though there's a lot to teach in 6th grade, they will have a better foundation. They'll have a better understanding. They'll know what a push and pull is and how it works and how it acts in every way, shape, and form, because it's so intentional a progression. The other,
question.
yeah.
How much access do we have to the resources from EduSmart?
If you're
District
not a
partner.
district partner, yeah.
Well, and then how do we know if we're a district partner? Because our district doesn't always share that information very well.
What district are you in?
Austin ISD,
You are a district partner.
so we are. Okay.
Mhm. Yeah, you'll have a subscription.
Okay.
So for if you're not a district partner, like you would not necessarily have access to the videos and things, but all the written components you would. We also offer a free trial, so you could go in and get like the links, and then you would have access to that. But anything like the scope and sequence, the vertical alignment, the teacher like alignment activity that we did, all of that is freebies. Like you have full access to all of that. So as far as what I'm showing you right now, any of the documents you could get, but this is really for us. This is for us as teachers to really start understanding and putting together how this should be taught. Like you need to know, not only know this information yourself, but be able to understand like this is what they're looking for when they're talking about this TEK.
Oh, and I understand that and I appreciate it, but as I'm planning lessons and stuff, I want to know how
Oh,
much
yeah.
I can pull on you guys. And it's
Absolutely. Well, see, that's the best thing is EduSmart has you covered. Like as intimidating as this might be, and I'll just go in and show you real quick because I think most of us here are EduSmart customers, especially today. So, Ms. Wolf, you're 5th grade, right? Or 6th grade?
sixth.
So
I'm 6th grade.
this is kind of the EduSmart library for what you would have available to you.
Okay.
And under force, motion, and energy, we have all of those resources I'm showing for every single standard. So all I was showing here was the forces acting on an object.
Right.
And that was the instruction module. You also have your student reviews, engineering design challenges. With that instruction module, of course, we have the note-taking guide, which is 3 parts. It's a fill-in-the-blank closed style note-taking guide with word bank. And then it's going to have a graphic organizer that brings in your science and engineering practices.
Are those paper copies or digital or both?
Both.
Okay, so I can put my digital on Canvas, or well, we
Correct.
call it Blend, but okay.
Correct. And then the third part is a journal prompt, and it's going to bring in your recurring theme and concepts. So, and this comes with every single instruction module.
Perfect.
Not only that, but you also have, so again, this is just that one. You have readers, activities. Here's your scope and sequence. So that's for next year, again, just to be clear on that. But we have teacher guides for each of them to help you understand how to do
Wait a
it.
minute. Now the scope and sequence is supposed to be for next year, but if we're starting in 6th grade this year, I can use it this year, right?
Yeah, well, let me double check with Austin because it depends on how your district has chosen to set up their renewal. But yes, you would have access to that by grade level. So if 6th grade is going ahead and implementing those standards, then 6th grade would have access to the new platform, and all the other grade levels are on our current platform that they've been on.
But if we have it, we're on the current.
Yep. Well,
okay, because the district hasn't let us know yet.
Oh, okay. So yeah, it's really going to depend on your district decision of what standards they're going to instruct on. However, the current platform has all of the same stuff. It just doesn't have the science and engineering practices and recurring themes. Okay. And some of those, so like right now, you would still have all of this instructional content. You just would have it for the standards that you actually need to teach. So whether that's the new ones or the old ones. The last one I want to show is this little engineering design challenge. So speed and velocity, it can be really fun. In this particular one, our mascot, the Rivals high school mascot has been stolen. the night before the football game, and we're trying to save our friend who was accused of stealing it. So we have to calculate whether or not our friend could have ran that far and gone in this correct amount of distance. So really putting them that context into something the students would super relate to. Like they would be so engaged in that because their friend has been accused. Oh my goodness, tap into that sense of injustice that students have and make it fun for them. So they're still doing all the work. They're still graphing, showing all the times and distances and everything, but they're doing it in a really, really fun way. So that one's another little freebie out there for you. I'm going to skip this one for today because of a time period, but electromagnetic waves, the way we're teaching them is very, very different as far as it is now practical application of how we're using them today on Earth in every possible way, not just to explore the universe, but also how we look at the human body, how we look at social media, all those things that we use this for. It really gives the students a much more grounded application for it. So it's kind of exciting actually to see that change. I thought that was a really good change.